Okay, so we're going to take a look at the derivatives of exponential functions when they have bases other than e. So in this case, it could be like 2 to the x power, 3 to the x power, 15 to the x power, just something other than e. Now, the reason why that's important is when we're taking the derivative of something to the x power, the derivative is the natural log of the base times that same expression. Now, the reason why we didn't see that natural log with e, it was actually there, but we didn't see it because the natural log of e is just 1 times e to the x. So this just said, okay, well, the derivative of e to the x is e to the x. Now, when we have other bases, that natural log is no longer going to cancel out. So we'll have to introduce the natural log of that value times that expression, all right, of that base. Now, sometimes we also have something other than just to the x power. So we also would have to multiply, right? This piece right here is just the derivative of whatever the exponent is. So this is the derivative of the exponent. All right, let's take a look at some practice with this and kind of give this a quick look here. So if we want to find the derivative of f of x is equal to 4 to the x, we would just say, okay, well, f prime of x is equal to the natural log of 4 times 4 to the x power. Now, we could multiply by the derivative of x, but that's just 1, so we don't have to include that 1 at the end. Now, taking a look at 7 to the 3x plus 2. So again, kind of keeping in line, looks more like our second rule. We have something other than x as the exponent. The derivative of this one, f prime of x, would be equal to the natural log of the base, so the natural log of 7, times 7 to the 3x plus 2, keeping that exactly the same, and then now multiplying by the derivative of that exponent, so times, in this case, 3. So remember, the derivative of that exponent is 3 here. So our final answer is just this whole thing right here. Now you could rewrite it in a few different ways, but that's your answer. Sometimes the exponents are a little bit more complicated. They have a little bit more going on. So if we're going to differentiate y equals 5 to the x squared plus 2x, we're going to end up with y prime is equal to the natural log of the base, natural log of 5, times 5 to the x squared plus 2x times 2x plus 2. Now just make sure you have those parentheses there, right? The derivative of the exponent has a little bit more going on. It's a binomial, so we have to contain that in parentheses. And there you go. That's your final answer there. So take a look at the back to get a little bit more practice. If you need a little more work with this, there is some other assignments to practice, but otherwise you can move on to the next lesson.